Our next topic is domain and range. To introduce domain and range, I want to go back and give you a little bit more formal definition of a function. Before we said that in a function, each x pairs with just one y, or each input has exactly one output. We could also say a function is a relation in which each element of the domain is paired with exactly one element of the range. So let's review what domain and range means. And to do that, I want to bring in a guest, my cousin from West Virginia. I'll let her introduce herself. Hey y'all, my name's Dixie. I'm Mrs. Taylor's cousin and I teach math too. I love math and I specifically love to talk about domain and range because domain and range has a real personal connection to me because my name is Dixie and my brother's name is Roy D. We call him Roy D because his middle name's Dwayne and my daddy's name is Roy too, and so we call him Roy D so we don't get him and my daddy mixed up. So let me tell you why I like to talk about domain and range. Because my name is an acronym for domain, and Roy's name is an acronym for range. And let me tell you how this works. First of all, let's start with the D in my name. The D stands for domain, as you might expect. Now, what would the I stand for? Well, the domain is the set of all input values in the function. Input values. Now what about, which of course are the x variables. Okay, so we can say input values or, and I want to write set of all possible input values or x variables in the function. Now why would I want that last I? Well, that input variable or that x variable is often called the independent variable. It's called the independent variable because I get to pick it. I can pick anything I want that fits in the domain into that function and then figure out what y means. So I pick the x and figure out y. So it's called the independent variable. Now let's look at Roy's name. Well, you guys are not too dumb, I imagine, so you know that R stands for range, and I bet you can figure out what most of the other letters stand for too. Yep, output. These are the output values. This is what happens when we put a number into the function. We get an output, and of course that's the y variables. And if we have an independent variable, then whatever we put in for x is independent, and what we get for y depends on what we put in for x, so that's the dependent variable. So this is just kind of handy to help you remember. For those of you who math words, you kind of forget which one means which and you get them mixed up. Think of Dixie, domain, x, and Roy D, range, and y. The inputs and the outputs. Now I'll give you back to Mrs. Taylor. I will let you know, though, every once in a while I'll come back and visit and teach a bit, especially if Mrs. Taylor's sick or something. I'll come in and sub. I love to come teach math. It's so much fun. Bye, y'all. Thank you, Dixie. That was great. Hopefully that'll give you a really memorable way to remember domain and range. Now we're going to talk about how to find domain and range using graphs in this video, and the next video we'll talk about how to find domain and range from equations, which students usually find a little trickier. So when we look at domain and range, so I wish I had a little hand or something. You could see me pointing with my hands, but what I want you to look at is here's this graph of a quadratic equation, a parabola, and notice it has little arrows here. And if we were to talk about what are the possible x values in this function if this graph were to keep going on forever? So I want you to recognize that when this is going up, it's also going a little bit to the right, and when this is going up, it's also going a little bit to the left. So it keeps going up, but it also keeps going to the right, and this keeps going up, but it also keeps going to the left. So if I were to go anywhere on the x-axis, I could find a point on the y-axis. There's a point at 0, 0. For all the positive x values, I can find y values on the graph. And if I were to go far, far out to the right and go up, 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 if I went up high enough, I would find a point way up here on the graph because the graph keeps going out to the right. So there isn't any x value that doesn't correspond to a point on the graph. Every single x value, I could find a y value on the graph. So the domain is all real numbers. Now, if I'm looking at the y value, now I'm looking at the y-axis here, and I'm going kind of sideways out, and I'm thinking, okay, which y values correspond to some point on the graph? Well, I can see that 0 goes with 0, okay? If y is 0, then there's a y value 0 on the graph, and I can see that all of these parts of the graph have positive y values, and the graph keeps going up forever, so it looks like I could pick any positive y value and it would correspond to some point on the graph. But notice down here below the x-axis there isn't any graph down here. So that means there aren't any values that there aren't any points in the graph that correspond to negative y values. So the range is all non-negative numbers. When we say non-negative, we mean positive or 0. Okay, so when we see if you say negative, it's just negative. But when you say when you say positive, it doesn't include 0. But when you say non-negative, it includes 0. So I'm just going to write that down. Positive not equal to 0. Okay? But when we say non-negative, that includes 0. That's just kind of a little math terminology for you there. However, I would probably just write it as y greater than or equal to 0. So let's take a look at these 4 equations or graphs that we've seen before, and let's find the domain and range for each one of these. So when I look, notice I've got these arrows. So this tells me the graph continues to extend to the right, but it also continues to extend up and down, because notice that it is getting bigger in the y direction as it moves to the right. It's kind of going at an angle. So not only is it going to the right, it's also going up, and not only is this going to the right, it's also going down. So if I go to the left, however, notice there isn't anything to the left of the y-axis. So I have no negative x values included. I have an x value of 0, and all x values that are positive all correspond to points on the graph, and including a point way out here would still correspond to some point on the graph. So I can say that x is greater than or equal to 0, but there's no negative values for x on this graph. Now if I look at y, I have this upper section of the graph has all positive y values, and it's going to continue to go up very slowly, but it's slanted up, so it's going to continue to keep going up. Down here I have negative y values for these points, and it's continuing to go down. So I have and I have a point where y is 0, so I have all possible y values. So we'll say for the range it's all real numbers. Now there's a symbol for that, and that symbol is a double line, an R with a double bar like that. That's also a symbol for all real numbers. Now, second graph. First of all, something I need to tell you about this graph is this graph has what's called an asymptote on the x-axis. The graph skims along the x-axis but never actually crosses or touches the x-axis. It just skims along and gets really close to the x-axis. So there isn't any place where the graph touches the x-axis. So y can't equal 0. Okay, y can get really close to 0, but it can't equal 0. Now you notice that the graph is going diagonally up and to the right. So that it's going up and it's going to the right. So that means y continues to get bigger and x continues to get bigger infinitely. Okay? Then we see over here that the graph is going to the left, and it's also continuing to go down, but like we said, it's only going to go down to get really close to the x-axis. It's never going to cross the x-axis or even touch it. So just to let you know about that. So let's look at the domain first. Does the graph go all the way to the left? Yes. Does the graph go all the way to the right? Yes. Very slowly, but it is going to continue to go to the right. There aren't any gaps in the middle, so the domain is all real numbers. How about the range? Does the graph continue to go up? Yes. Does the graph continue to go down? No, it stops above the x-axis. It does not go below the x-axis. It does not touch the x-axis. So y is not 0, but y could be any number bigger than 0. So we can say that y is greater than 0. Now these next two are kind of unusual. So I actually want to make a little table of values for this. Let's look at the x and y values for this first graph. So let's pick a few points here. 1, 2, 3, 4, 5 of these points. So we see the point -2, 2, -1, 2, 0, 2, 1, 2, and 2, 2. And we've done this before. So what do we notice about x? Can x keep going? Yes, it goes to the left and it goes to the right. All right, so it can go as far as we want to either direction. So the domain is all real numbers. How about the range? The range is just y equals 2. There isn't any other value possible for y. So there's the value y equals 2. Now when we look at the next one, and we've done this before on the other page, so I'm not going to write out all the values for x and y, but we notice it keeps going up and down forever, so y can be as high or as low as we want. So an infinite number of different y values are possible, so its range is all real numbers, but the domain is only x equal 2. Okay, so that's how you find domain and range using the graph. And we'll have some more practice with that with some more complicated graphs as we go along.